Alright, here we are with part 2. And now we're going to get into specifically how we define acid and base. There's 3 different methods for defining it, and we're going to have to use all of them because sometimes acids don't always look like acids, and sometimes they don't always look like bases. And so we need to have these other definitions in order to explain the acid and base properties of other things. So, the first one we're going to get into is the Arrhenius definition. Okay, it's another one of those somewhat unfortunate names in science. The Arrhenius definitions are this. Acids are substances that dissociate in H2O to produce hydrogen ion. And this is pretty much the primary definition we're going to use. That when a substance is mixed into water, it produces an abundance of the H plus ion, so it gives off the H. Bases then do the opposite. They dissociate, producing the hydroxide ion. Now, dissociation, to make sure that you guys are clear on what's going on. In dissociation, it's the breaking apart of a substance into positive and negative ions by reaction of the substance with water. Okay, so for example, salt is sodium chloride, NaCl. NaCl. And when this dissociates, it becomes Na plus Cl minus, and those should be superscript. Okay, and this here in and of itself is the dissociation that of the sodium chloride. And this is what happens whenever you put salt into water. It doesn't stay as salt and chloride together. As sodium and chloride together, it separates into positives and negatives, and this is what gives it its electrolytic properties. That's how it can conduct electricity. And we'll see if we can't do something like that with some of my electric kits here in a bit. Right, okay, so the Bronsted-Lowry definition then is a little bit different. And instead of dissociating in water to produce hydrogen ion, it's any substance that can give up a proton. It can donate a proton, or the hydrogen ion. So, mind you, what does a hydrogen ion look like? Well, if we go back to what atoms look like, remember, we have this nucleus in here that is this stuff in here has got a positive charge. And then has an electron going around it, particularly for hydrogen. It's got an electron going around it. But if it's an H plus ion, well, what does it do? Well, it loses this electron. It just flat out goes away. And so what's left is just the proton, just the +1 charge, which is just the proton, the subatomic particle, the proton. Okay, and so that's really what we're dealing with. In fact, there's another name for acid-base chemistry, and it's sometimes called proton chemistry. And it's sometimes called proton chemistry because that's what we're dealing with, is the dissociation and the movement of protons through our solutions. Now, a base is then any substance that instead of donating protons, it can accept the proton. So there's some bases out there that don't have the OH on it, but because they will accept the proton onto, say, a lone pair of electrons, it's considered a base. And one of these things is called ammonia. Remember how ammonia was built? It's got this. It's got a hydrogen, another hydrogen, another hydrogen, but then it's got this lone pair up here that is just all by itself. And this has a local, let's see if I can draw this here, a local negative charge right here. And the proton is going to want to come down and it will be attracted to that lone pair. And all of a sudden what you have here is, instead of this being a proton, because remember this is also a hydrogen ion, this becomes another hydrogen and this whole thing has a +1 charge to it. And this is what happens when it accepts the proton. And so this right here would be, this whole scheme right here would be considered is the base. So this right here, this NH3, this is considered a base because it accepted the proton that came from another acid. Okay, and this is ammonia. This is NH3, and this is one of our more familiar bases, and we use it as it's why we use it as a cleaning solution, because because bases are caustic and they get rid of organic tissue, and that's usually what we have sitting on our counters and that sort of stuff is organic tissue that we want to clean. Okay, the third type of definition is the Lewis definition, and according to the Lewis definition, an acid is any substance that is an electron pair acceptor. I need to change that. Electron pair receptor. Okay, and that's actually what's going to be on the next one. So a base is any substance that is an electron pair donator. So let's get rid of that electron. Let's see what I can do with that. Make that, and that, and that, and that. Just go. Booyah. Ooh. Electron pair donator. Okay. Okay, now, there is, the H plus doesn't really sit by itself, and this is a concept that is a little confusing. When the H plus in water dissociates from one of the acids, it actually hooks up with one of the water molecules. And it does this on one of the lone pairs on the oxygen. And it creates this H3O plus, which we call the hydronium ion. And this is actually what the acidic particle is. Okay? H plus is just the shorthand method, however, to really represent H3O. So the two of them are pretty much interchangeable, except when you're getting really specific later on. So they mean the same thing. Okay, so we need to establish right here that there is a difference between two different words. That there are two concepts that are opposites to each other. There are two concepts and they have opposites, but they aren't really related to each other. First one is strong versus weak. And the other one is concentrated versus dilute. Okay, these are two different concepts that we're going to get into here in a bit. We're going to start with strong acids. And a strong acid, or a strong base for that matter, are acids that dilute completely, or 100% in water. Okay, they are strong, they're strong electrolytes, and they are highly acidic. Okay, now weak acids are those that don't dissociate completely in water. And they are weak electrolytes, and they are weakly acidic. Okay, so it's a good thing I have this pause button, because otherwise you guys would be hearing all of my hacking and coughing and, head phlegm noises. So, okay, so strong bases then are just like strong acids, except they also dissociate completely in water. They are also strongly electrolytes, and they are highly basic. Or alkali. Alkali is another synonym for basic. Okay, yes, that has to do with alkali earth metals. And the alkali earth metals, generally when they react with water, make bases. So that's why they're called, or even alkaline metals. That's why they are called alkaline. For example, there's our sodium hydroxide again, or potassium hydroxide, or calcium. You guessed it, hydroxide. Okay, that's page 2, and so we're going to pause there. That'll be part 2, and click the next one for part 3.